Welcome back, interweb welder students. Let's go ahead and start where we left off with section 2 of module 9, SMAW technique, weave beads and overlaps. Running a weave bead is significantly different from a stringer. There's a number of different ways, there's a number of different weave patterns that can be used. So practicing weaves with a 60-10, Practice running weave beads in a flat position using an 1/8 inch E6010 or E6011. After striking the arc, the electrode angle should be 10 to 15 degrees in the direction of travel and at a 0 degree work angle. To ensure good welding, remember lash. Lash is going to be some stuff that they're going to ask you about lash. So you need to know length of arc, angle, speed, and heat. Lash. The distance, the length is the length between the electrode and the base. We call it tight arc. Keep a tight arc. Angle, the travel angle and the work angle, the longitudinal angle of your electrode, and the traverse angle of your electrode in relation to the axis of the weld joint. Travel speed, we know what that is. Heat, that's your amp settings, depending on the electrode, base metal type, metal thickness, etc. Thicker metal, higher amps, thinner metal, lower amps. The weave bead is made by moving the electrode back and forth. Many different patterns can be used in the weave: zigzag, crescents, boxes, circles, figure eights, upside down C's, right side down C's, you name it. You know, essentially they're all some sort of a side to side that massages and manages the puddle. That's the bottom line. At the end of the day, that's what you're doing. You're wanting to make sure you're filling in your undercut, and you're wanting to make sure you're getting good penetration. You're not overheating your metal. You're not going through the metal. You're getting proper penetration. All those things rolled up along with your the way that you manipulate your rod is a component of the weave. So there's some examples of pause at the sides, the zigzags, the J's, the crescents. You know, some of these are just going to be dependent on the position that you're in and what you're going to try different things. And some things you're going to try, it's like, I've never done this before, let me give it a try. But depending on what position you're in, what kind of metal you're working on, there's just the variables. You can look at a puddle long enough and eventually you just develop your own. Don't take all these positions as this is it. You got to learn these. These are examples. You learn and develop your own and what works good for you. Weave bead. Here's this groove weld. And looks like it's got backing strip, or it's got a real tight root face, root opening. Looks like a single pass weave bead, which is kind of a no-no. You want to see multi-pass. Strike the arc, hold the arc, move the arc. Proper and improper overlapping of beads. Here's the proper, here's improper. You got excessive buildup and undercut. Undercut, underfill. Flat surface proper, and improper is all over the place. This looks like good pad of beads workout right here. Electrode work angle. Here's a pad of beads. Working an angle and arc control are important for overlapping beads using 70-80-10 electrodes. Turn the page. Fillet welds. Profile and ideal, acceptable and unacceptable fillet welds. Unacceptable, acceptable. Convex, concave, familiar. These are all familiar terms. There's some overlaps. Yeah, it hangs out right there at the bottom. Incomplete fusion. Profiles of equal and unequal fillet welds that have a uniform concave convex face are shown. Welding codes generally only allow for non-uniform. Okay, I think I'm getting a little ahead on the left, so let's catch up on the right. Bead, keep your bead straight, uniform, smooth, flat, craters, restarts, have to fill them in, no porosity, no excessive undercut, no inclusions, no cracks, no overlap. We know all those terms, and we know what to do with them. Continue welding weaves until you make acceptable welds every time. Practicing weave beads with 70-18. Do not whip it. It's more of a side to side. Bottom line, just keep the electrode in the puddle. Don't let the electrode leave the puddle. That's the number one thing you got to remember. In addition to not whipping it, anything excessive with the 7018 is going to give you a less than desirable result. Weld defects such as porosity, hydrogen embrittlement can occur if the arc is too long arcing, or if your rod leaves the weld puddle. The arc can be moved within the weld puddle to control bead shape. It's important to note that there are several weave techniques that should not be used with the E7018 electrode. They are circle, box, and figure 8 weaves. And that's probably because you end up leaving the puddle. I am a big fan of that upside down C, like I'm doing with my mouse right now. Up, 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 pause, up, pause, up, pause. That's, your electrode is always touching the puddle, touching the puddle, touching the puddle. That works really good. Or just freaking straight drag it. Overlapping beads with a 6010. Overlapping beads are used to build up surface and make multipass welds. Both stringers and weaves can be overlapped properly. Overlap beads, when viewed from the end, will form a relatively flat surface. Mark out a 4-inch square on a piece of steel. Weld a stringer bead along one edge. Properly dispose. Okay. After striking the arc for the next stringer, travel angle 10 to 15 degrees. There you go. Pad of beads with 6010. Basically, it's the same rod angle. Continue running stringers until the marked square is covered. In red, only welding coupons for practice should be quenched. Never quench actual welding work. That's a test question. Another one, keep a short arc. Do not whip the electrode. Talking about 7018 again. 2.3.4, yeah. This is 2.4 over here. We haven't got there yet. Repeat your welding overlapping using a 7018. Use a pad. Build a pad using stringers. Then repeat building the pad using weaves. Keep a short arc. Do not whip the electrode. Fillet weld. A fillet weld is a weld that is approximately triangular in cross section and used with T, lap, and corner joints. Fillet welds. The two types of fillet welds are convex and concave. Hello, Red. That's question. Two types of fillet welds, convex and concave. So if you saw a question, what are the two types of fillet welds? Convex, concave. Hello, people. Couple of trade terms here. Weld face, leg, weld toe, root, pause. If you want to slow down and read those. Convex, concave. We talk about these in lab all the time. If it's got a hump on it, that's the convexity. If it's got a dish in it, that's concavity. Concavity. Convex fillet weld. This one is a concave. See how it's got a dish shaped? This one is a convex. See how it's got a hump shape? Just learn them. Memorize them. Convex, concave. So you got convex, flat, or slightly concave. That's okay. It's the excesses that are a problem. You can pass a weld inspection with a convex, a flat, or a slightly concave. What you can't get away with is something that is excessively convex or concave. Although a slightly non-uniform face is acceptable. Equal leg fillets, unequal leg fillets. Feel free to pause anytime you want to read something. If you have information in here, I think you guys know all this stuff because we talk about it every day. But if you see something you'd like to review, just click the screen and pause. In red, here we go. Wonder why it's in red. That's question. A fillet weld is unacceptable if the profile has insufficient throat, excessive convexity, excessive undercut, overlap, insufficient leg, or incomplete fusion. Each one of those things is a single item that could make a fillet weld unacceptable. So it's important to know what each one of these are. Fillet welds require little base metal prep except for cleaning the weld area and removing any dross from cut surfaces. The most common fillet weld is lap joints and T-joints. We know what T-joints are. There's one right there. Here's a lap where you lay two pieces, you lap one over the other, you throw a weld down. Brrr. Lap joint. horizontal. This is a vertical. This is a 3T, and a 3 lap. And the overhead. So 2.4, let's catch up over here. Profiles of convex and concave. Convex, concave. Fillet weld positions are determined by the weld axis. 1F, 2F, 3F, 4F. You guys know what those are. Feel free to pause if you want to review. 2.4.1, proper multi-pass 2F weld sequence. This is a multi-pass. Right here, multi-pass. We've been doing single passes. If you want to do multi-passes, you just say you lay them out. Weld 1, weld 2, weld 3, weld 4, weld 5, weld 6. That becomes more important in the groove welds to us. We're not going to do a lot of multi-pass fillet welds. And those are the trade terms. Let's go back over here and turn the page. 2.4. Practicing vertical fillet welds with 6-10, 3F. Here's some details. Tack them together. Run the first bead. Pass 1, pass 2, pass 3. It's pretty cool. Run the second bead using the weave technique, just as you see. Tack it together. Run the first bead along the root. Use a whip or a whipping paw, I believe is better. Drop it back into the weld puddle. There it says pause. I'm glad the book agrees with me. Pause in the weld puddle. Fill the grade. So root pass on T joint 60-10. Whipping pause. Second pass is a weave, such as a C. Slow motion across the face. Highlight that just because I think it's important. Properly dispose. You're all big on disposing. Continue to run weld beads. Properly dispose. Have the instructor inspect the weld. The weld is acceptable if it has the following characteristics. Every time, same characteristics. This list is on every inspection. You know how to inspect one weld, you know how to inspect a lot of welds. Tacking and aligning. Test your joint heat dissipation. In T-joints, the welding heat dissipates more rapidly in thicker or non-budding member. On various bead passes, the arc may have to be concentrated slightly more on thicker T-joint vertical plate. Oh, here's something in red. Repeat vertical 3F using, for root pass and stringer beads, use a quick side-to-side motion, moving the electrode without removing the arc from the weld puddle. 70-18. Anytime you see the words, don't remove the arc from the weld puddle, think 70-18. That's what they're talking about. Overhead. Steps. (10-15) angle. Slight oscillation, circular side to side, and overhead. Around the second bead, overlap 75% of the first bead. That's a lot of overlap. Pass 1. That's real similar to the other. Vertical weave. To help control undercut and alternate patterns, such as a small triangle weave, can be used in vertical welds. Repeats 5 and 6. Inspect the welds. And that's it. Section review. These are all questions that you'll see on your test. And that's it. In summary, striking an arc, running stringers and weaves, making fillet welds are basic and essential skills. Even the method used striking arc can reject a weld. Developing and honing skills in the booth, boys, allows welders to progress in more difficult procedures. It's important to practice these welds until acceptable results can be achieved. Welds can be formed in different positions: flat, vertical, horizontal, overhead. It's necessary to use various types of electrodes in welding in different positions. The practice provided for this module provides trainees with the first opportunity to create a weld bead and experience how different electrodes perform in different positions. That's awesome. We're through with this module.